Okay. So, Reese, thank you for doing your test. Andrew, and Mac, and Bo, these will be in my office over there today. If it's not done from after this class all the way through, if it's not done by 8th period today, goose egg stays in there, and you cannot make it up. Got it? You what? Yeah, I'll walk right over there with you. Sweet. So, that makes sense? Over in that office, not testing center. All right, so after a few emails back and forth amongst us CP teachers, we have decided that we would move the group portion of the test will be on Monday after break. So it'll be basically like a review for you guys. You get to work on it together using notes and whatever and each other. And then Tuesday will be the actual test. So today I am finishing up our review. So there is no movie to watch. I don't know what part of watching a movie you guys get in math, but it won't happen in here. I'm sorry.
Everything is
No. We'll not watch it. All right. So, guys and girls. Earbud out, please. So, some of you have completed all of the Schoology you need to complete. Congratulations. Some of you have not. Okay? If it's not done by tonight, sorry. You've had a long opportunity to do it. And there's a 30-point quiz that's in there. That will indeed help your grade. Some of you have some nice-looking grades right now because you are doing the Schoology. Some of your grades in here stink because you've done nothing. And then your parents are like, well, what can they do to catch up? Tell you what, how about they take this next year? That's how they can catch up. Okay? Guys and girls, and this is talking to those who are doing nothing. Those of you who do nothing, and you're a freshman right now, you're going to repeat your freshman year. I've looked at some of your grades in other classes of those of you who've done nothing. Some of you in here who have done nothing, if I summed up all of your classes percentage-wise, you wouldn't have a passing grade if you summed them all up. Meaning there's people in here and in other classes who have like 7-8% in all of their classes. If you add them all together, they wouldn't be passing. That's pathetic. And that's going to those who are doing nothing. Those who are doing nothing, figure it out. Okay? Because you will repeat all of these courses that you're not passing again. Oh, I'll just do it all over spring break. Really? Are you sure? You've done nothing while we've worked throughout the semester. Now you're going to choose, okay, here comes 9 days, I'm going to do it. Yeah, right. And I say that with sarcasm because I've been in teaching a long time. Okay? Which is great. I enjoy it. I love it. But please do not take it that you think, okay, I have 9 days off, so I can just recharge and catch up. Doesn't really work that way. So before we had our days of snow, which I'll take anytime, we had started on graphing quadratic functions number 14. So if you have this worksheet, get it out. This would be a subtle hint to those of you who do nothing to get it out. So it's pages 77 through 80. I want to run through it, see how we do. All right, looks like the very first question. I've tried to mimic it the best I can. They give you a parabola, and they want you to go with the domain first. What would the domain of this parabola be? What would this be? Does it go forever right, forever left? There you go, thank you. Negative to positive infinity. The range it's going down to negative infinity. How do I know it's going down to negative infinity? It opens down. Where does it start going down to negative infinity? At 4. It's a square bracket at 4. And it's going to negative infinity. Okay? You also could have added negative infinity to 4, close bracket. Vertex appears to be 4, 4. Axis of symmetry, x equals 4. Is the vertex a minimum or a maximum? It is a maximum. What is the maximum value? Remember, it's the y component of your vertex. 4. And does it appear we have roots? It does. Where does it appear across the x-axis? 2 and 6. So you can write it like this, or you can write it as an ordered pair, 2 comma 6, or excuse me, 2 comma 0 and 6 comma 0. And where does this graph appear to be decreasing? Here or here? Blue or green? It's increasing here. It's decreasing there. Okay? So, if it's, oh yeah, I'm asking for both increase and decreasing. So decreasing first. Decreasing is going from 4.
How's that decreasing?
The roots do indeed go up. So let me answer both real quick, and then I'll show you graphically what's taking place. Is that okay? And then it's increasing from negative infinity to 4. Okay. So this is how it's decreasing. Let's see, I can do this. You might have heard a term a long time ago, something called a tangent line. Tangent line is a line that touches the graph exactly once. Is that okay? A tangent line in trigonometry is the sine over the cosine graph. You divide it together, so it has a different meaning there. But as far as math goes, I could take an infinite amount of lines that are doing this, and they are tangent to the graph. So all of these graphs right here all have it's a line, a straight line, has a positive slope. That means it's increasing. As I get to this side, they start going downward like this. And so they have a negative slope, and that's where it comes from. So it's a calculus concept that we're hitting in algebra, but not showing you the actual concept of it. So that's basically what it is. So any line could be made up of an infinite amount of tangent lines, because a tangent line could be an infinite amount of points to create your graph. And I think that's the best representation I've ever done with that. Thanks for asking how to do it. I'm happy I was able to work. So increasing means positive slope. Decreasing means negative slope as far as the tangent lines. We haven't really talked about those other than just a brief discussion. Cool? All right. Next problem. We have this equation. They want the line of symmetry. They want the vertex. They want you to graph the 1, 5, 3, 5. But this will graph at 2, 6, 10 because it's a lead coefficient. They want to know where it's increasing, and they want to know the range. Okay. So in order to find let's find the vertex first. I'm going to use the negative b over 2a, and then plug in. And then negative b over 2a is negative 8 over 2 times 2. So the x component of my vertex is going to be 8 over 4, which is 2. So our axis of symmetry is x equals 2. And then 2 comma, I don't know, let's plug it in. 2 squared is 4, times 2 is 8, minus 16 plus 7. So 8 plus 7 is 15, minus 16 is negative 1. There's our vertex, so 2, negative 1. And we're going to graph, it'll be double at that rate. So I'm going to go right 1 up 2, left 1 up 2. From here I'm going to go right 1 up 6. And left 1 up 6. Okay? Where is it increasing? It's increasing from here to here, right? So it's increasing from 2 to infinity. And then the range, it's going to go to infinity. And our range starts from here. So what do we got? What is that? -1, and it's a square bracket because we include it. It starts there and goes to infinity. This is a really good review. You know, I like all the review we've done. I won't take back the snow days. I think it was great that we had them, but boy, I think that you guys really would have been prepared nicely for this if we had the test today, if we didn't have those snow days. But I'm not going to. I would not do that to you guys. That's not fair.
I think it's kind of silly today because most people aren't even going to be here because I have a vacation on Friday.
You're right. You're right. I get you. You know, unfortunate for us. Yeah, we could have taken a religious day.
Yeah. Good taking a religious holiday.
There you go. All right.
Yeah, no Catholics are here.
So let's see. If you don't want to be here, get out now. Mac, go sit in the hall. I've turned and looked at you twice. You're screwing around. Angelo, go with him. Last chance. I will not direct myself to you one more time. Next time you're going to the dean, stay where you're at, watch what we're doing. Trying to review, okay? If you're screwing around, you don't need to be here. All right, I want to take this and somehow make it work with this. The nice thing is this A value will fit here. So far I know this. So far I know that. Is that okay on that transfer? I can find the vertex of this by using negative b over 2a. And plugging it in. Okay, so I get negative 12 over 2 times negative 3, which is 2. Okay, and then plug that in. 2 squared is times that, that's negative 12 plus 24 minus 9, I think. Did I do that right? So negative 12 plus 24 is 12. 12 minus 9 is 3. So, HK. Okay? Realize, see this minus, it stays there. See this plus stays there. The only reason that minus would change is if that was a negative. The only reason that plus would change is if that was an opposite sign. So, plug it in directly. That's it. So the A value travels right along with it. The lead coefficient is the same as the lead coefficient on that. It tells you the direction it opens, it tells you the growth pattern. All right. I didn't want to graph all of the ones that are listed on that back page. 78, I think it is. Are there any? I think I have 3 or 4 that I could do. Is there any of those on page 78 you would like me to take a look at? What do you got, Reese?
10 and 11.
10 and 11. I like it. So I'll go 10, 11. Anybody else? 12. 12? Yeah. One more? Go ahead. 6, yeah. And that's it. All right. Starting with number 6. Okay, sketch the graph of each. So if we find the vertex on number 6, our b value is 0. Is that okay? And if I take my b value being 0, I get negative b over 2 times a, so I get negative 0 over 2, which is 0. So my vertex is going to be at 0, comma, plug 0 in, negative 8. That's my vertex. So 0, negative 8. And it graphs at 1, 3, 5. So right one up 1, left one up 1, right one up 3, left one up 3. There it is. And they just wanted you to graph it. They didn't ask for anything else, did they? Nope. All right. Number 12. Good one. I like that one. Y equals x minus 3. This one is already factored. I don't know my a, b, and c value because it's already broken apart. I guess I could distribute over and find the a, b, and c. Or what I could do is I could say x equals 0. And then x minus 3 equals 0. So x is equal to 3. So 0 and 3 is where it crosses here and here. So what is halfway between 0 and 3? 1.5. So right here at 1.5, that's the x component of my vertex. How do you think I would find the y component of my vertex? Plug it back in for the x's. Good. So I get 1.5 and 1.5 minus 3. 1.5 minus 3 is negative 1.5, so I go 1.5 times negative 1.5. 15 times 15 is 225, so 1.5 times 1.5 is 2.25, and it'll be negative, so there's my vertex. Let's see. Negative 2.25. There. Maybe? I don't know. And then graph it. So it's done. Number 11. This one also has the roots given. So this crosses the x-axis at 4 and at negative 2. So at 4 and at negative 2. So what appears to be halfway in between those? 1? Right there? That looks about right. Yeah, I like it. So at 1 comma, how do I find my y component of my vertex? Plug it in, so I get 1 minus 4, so I get negative 3. And 1 plus 2 is just 3, so that's negative 9. So 1, negative 9, down there. There it is. So one other one. Number 10. Oh, that one's kind of weird. It's backwards. It's backwards. So I'm going to go 2 plus x equals 0. X equals negative 2. 2 minus x equals 0. Negative x equals negative 2. X equals 2. So negative 2 and positive 2. What appears to be halfway in between those? 0, I agree. So let's plug 0 in. 2 plus 0 is 2. 2 minus 0. 2. So 0, 4? Is that right? Wait, this one's going to go upside down. Why? Why did that one go upside down? It's totally correct. Why is it upside down? If I multiply 2 plus x and 2 minus x together, so I get 4 plus 2x minus 2x minus x squared. So because they're kind of flip-flop, so realize sometimes on that kind of problem, this is a really good problem because it exercises that one, a lot of people are going to think, oh, wait a minute, why would it open upside down? There's nothing indicated. I don't have a negative out front. It's this negative here that is our culprit. And because they flip-flopped each of them. You okay? All right. Okay. What's my vertex? Negative 5, 3 is my vertex. Now, let me ask you this. Does it appear to grow at a 1? Negative 5, negative 3. Thank you. Does it appear that it grows at a 1, 3, 5? So from the vertex, did I go right one up, one left, one up, one? So what's my A value? 1. All right, so let's plug in what we know. I got y is equal to 1. Still with me? X. There's a negative there. I'm plugging a negative in. What do you think this is going to do? Plus 5. Ooh, that's the little trick on that one. And then this one is not going to be plus k. It's going to be minus 3. Take a look. Make sure you understand why the signs have flip-flopped a little bit. But that's our thing. Can we move on? This one, it's opening downward, so I know my A value is going to be negative right off the bat. Still with me? So I went right one and down 1, 2, 3. So what's A? Negative 3. Awesome. I don't know what my H and my K are yet. My vertex appears to be negative 1, 6. So what do we got? Plus 1. Plus 6. Notice the sign changed. So it's opposite inside, same outside. And this is the last problem I'm going to work for today. Okay? So they give you a parabola. H at t means the same thing as y. Negative 16t squared plus 96t plus 288. So we could change the t's with x's. The maximum height and time. Okay, so this is a parabola that's drawn. This is an item that is being thrown up with an initial upward velocity off of the building or an object that's 288 feet tall. So right here we're at 288 feet up in the air. We're throwing it upward with an initial velocity of 96 meters per second or 96 feet per second or something like that, miles per hour, whatever. And then it's going to come downward, okay? So basically this is the height of the tower. So we want to figure out what the vertex is going to be. The vertex is going to indicate the maximum height and the time. Okay, so if I go negative b over 2a and plug in, that should help us. If you have a calculator, this would be awesome right now. So that's going to be what? Negative 96 over negative 32. Is that 3? Okay. And then if I take this 3 and plug it back in here, I get negative 16 times 9. Where did that 9 come from? 3 squared. Plus 96 times 3 plus 288. I need help on this one. I can't do this in my head. What's negative 16 times 9, somebody? Negative 144. Thank you. And then what's 96 times 3, please? What is it? 288? 288 plus 288. Holy cow, what is all this? Okay. What is 288 and 288 minus 144? Well, they had it labeled as
432.
432? Okay. All right, so a question came, how did I graph this? Well, if you look on the graph, they have this as time in seconds. And then this is height in feet. So at 3 seconds, after that object has been thrown upward, 3 seconds after it has left your hand, it is at 432 feet. So at 3 seconds later, you are at 432 feet up. Granted, you had started at 288 feet. Okay? What does the y-intercept, or the x-intercept mean right here? Yeah, when it hits the ground. What does the y-intercept indicate? Not quite. Where you were at. You're standing on like a tall building, on top of a tall building at 288 feet. So this is the level that you tossed up. So the height of the building. Okay? So because you tossed it upward, it had an initial amount that had got going up positive. And then from here, right there, to right here, it's on its way down. So the going down time. Well, at 3 seconds, it reached its maximum. And just after 3 seconds, it's going to start heading on down until it hits the ground. And do we know where it hits the ground? Is it exactly at 8? I don't know. Do we know? Oh, shoot. When's it going to hit the ground? I think we have to do it. I would say 8. I'd go 8.0 seconds. So from in this region of time here. So from 3 seconds to just after 8 seconds, it's on its way down. So it's basically in a 5-second free fall. That might be a lot of time to spend falling. That might be one of those where you're like, can I turn the iron off? Wish I got a puppy. Splat. What do you think? We good to go? Yep. Should we just give the test tonight, right now?
No.
Yes.
Oh, come on! Okay. Love you guys. All right. I think we should do this way. We got what, 23 minutes-ish left? So there are 2 more reviews that are existing. That exist. I don't think that we are going to be able to do all of them, and I am not the guy to say, okay, over the next 9 days, let's do them. So from page 81 to page 87, there is review. I am happy to cover however you want me to cover from page 87 or any of the previous reviews. So if you ever flip over those pages, take a look. Page 81, it looks like we're just graphing those. We've graphed a lot. First look, let's just take a look at page 81. Is there anything on page 81 that you would like to see? Can I go to page 82? Page 82, is there anything you'd like to see? think we're set on graphing. I feel pretty confident with y'all. We've covered about every type of thing. But I'm looking down at 7, 8, 9, and 10. How do we go through those? Are we okay with those? 7 is you have a vertex at 1, 1 and passes through the point 2, 5. Number 8, you have x-intercepts of 1 and 4 with a y-intercept at -8. Number 9, you have a vertex at 3, -4, passes through the point 5, 4. Number 10 says you have x-intercepts at x equals -1 and at 3, and you have y-intercept at 0, 3. Write the quadratic equation in the form best suited for the given information. Sure. Let's do it. Ready? Okay. You have a vertex at 1, 1, and you have another point, right? So remember, you have standard form. You have factored form, and then you have vertex form. There should be an A, I guess, there. So you have to figure out which one works for you on this. I have a vertex. A vertex, we use which letters? Which letters are the vertex? H and K? Yes? Okay, does the first equation have H or K as part of it? No, I'm not going to use it. Second problem, have H or K as part of it? No, I'm not going to use it. Third one, does it have H or K?
Yes.
Yeah. What is this? What are those? X and Y. Okay? So, what's the only value I would not have on that third equation? A. So, I'm going to plug into this third equation. I have a Y value of 5, an A value that I'm not sure of, an X value of 2, an H value of that, right? And that's going to be squared. And then my K value is 1. Let's do the math. 2 minus 1 is 1. 1 squared. So I get 5. 1 squared is 1. 1 times A is 1A. What's A equal to? 4. Now I have enough information to do this problem. Okay, leaving Y and K alone, or Y and X alone, excuse me. I have 4x minus 1 squared plus 1. So you use the vertex form in order to solve it. You know the vertex is H comma K. You know the other point given to you is X comma Y. You good there? Number 8 says you have x-intercepts and you have a y-intercept at another value. So let's see. Number 8. You have x-intercepts at, and then you have a y-intercept at -8. So I don't think the first one's going to work at all. That's not going to work. I think that if I did this, does this yield to this binomial? If so, how? If I went from here to here, this would be equal to 0, right? And if I went x minus 1 equals 0, do I get x equals 1? What does this one yield me? There you go. So I like that right now. And I like that where this is going to go here and this is going to go here. But we have an a value that's going to dictate something. Okay, so I'm going to go y is equal to, I don't know what a is yet, but I'm going to go with this. But I think we have a hint up here. The y-intercept is always the c value, right? So if I multiply this out, I'd get -1 times -4 is 4. How do I make 4 look like -8? How do I make 4 look like -8? Multiply by -2. So there it is. Okay, so this indicates to you, how I got that is this times this gives me +4. How do I make +4 look like -8? I have to multiply by a greatest common factor of -2. Number 9, it looks just like the one we just did. We have a vertex at 3, -4. And we have a point at 5, 4. So I know that this equation is going to work nicely. Isn't that what we had done on that last one? Yep. So what am I looking for? What's this? H, K? What's this? What am I looking for? A. That's 2 squared, which is 4. I'm going to add 4 to both sides, right? What's A equal to? 2. Okay, so then we'll plug it back in. So I'll plug in here, here, and here. There it is. I should give you these equations.
Yes.
Maybe I'll, if they're not written on the test, maybe I'll just post them like here. And then number 10, we'll call this last one because I know you guys are excited. Spring break is on its way. Okay, we know where the x-axis is. This leads to x plus 1, yes? This leads to what? Cool. And we have a y-intercept of 3. So hang on, if I take this and I take this, if I were to multiply our last terms together, I get -3. I want my y-intercept to be +3. What do I have to do to -3 to make it +3? Multiply by -1. So y equals, this is an upside down parabola. Guys and girls, if you want to take a look at those next couple pages on your own, you are welcome to come up and ask me questions on anything, and we'll just shoot over on the board. Remember, we do have the shifting right and left and the up and down, flipping over the x, flipping over the y, things like that. So if you want to see that, come on up. If you are done cramming for this test, you have 10 minutes to chill. Yeah.
So are you going to post a view answer sheet that has mentioned check our answers?
Yeah, I'll do that. Tell you what, so I will post problem 17, 18, 19 from that first one. And I think on page 85 you're okay. Ben, you're okay with all the graphing, right?
Yeah, it should be.
And then
I'll email you if
This is from page 87. I think if we did 9, 10, I think you're okay with 11 and 12. So yeah, I'll post up to that. Is that all right?
Yeah, thank you.
Yeah, it'll just be at the tag back end of this video. Is that cool?
Yeah.
Deplane. All right, this is a little bit less more of the review. This is up from page 84 if you wanted to follow along. So let's see, in red, looks like we're going to shift right 5 and down 3. So each point, so remember I'm going to shift right 5, so 1, 2, 3, 4, 5. And then this little went down 3, 1, 2, 3. And so this parabola would have shifted like that. If I had the negative out in front, I'll do this one green. The negative out is out in front. Remember, it rotates it. So this is going to come over to here. And then this would have been left 4. Okay. So it's going to come left 4. So 1, 2, 3, 4. So this is what this one would have appeared to be. Sorry, that one's not there. And then in blue. Okay, so that means it's going to flip. So the whole thing is going to go upward now. So it would come over here and then gone up. And that's what that one would have done. Number 18. The black. So the blue is our parent, so it's going to go right 1, up 2. So I'm going to go right 1, up 2. Right 1, up 2. Right 1, up 2. So that's what that looks like. And then right 1, up 2. Right 1, up 2. So there's the black. The red, the negative x means it's going to flip over the y-axis. So at this point, this point is going to come over here. This point stays here. This point comes over here. This point will come over here. This point will come over here. So that's what that one looks like. This is going to flip it over upside down. The whole thing upside down and down 5. Make that green. So it'll go down 5. So it's going to flip over. So this becomes upside down, and then so this point would come down 5. 1, 2, 3, 4, 5. And this one comes down, flips over, comes down 5, 2, 3, 4, 5. This one just comes down 5. Doesn't really flip over anything because it's symmetric. This one's going to go down. So it's going to flip over. So if this came up here, it's going to go down 5. And this one flips over. Comes down here. I think that's what it did. So that's what that would have done with blue. This one was the transformation from here to here. Well, I know it's going to be a negative. So we have a negative out front. And it shifted 1, 2, 3. So shift left 3. And down 2. So this would be a negative f at x plus 3 minus 2. Go to there to there. This one, this means the whole thing is going to shift down 2. Okay, we'll do that down 2. So each point, 1, 2, 2, 2. So that's what that one's going to look like, just shifting down 2. This one, it's going to shift up 4, and it's it's going to flip over. So each point. So if I go up 4, let's do this in green. So if I go up 4, 1, 2, 3, 4, and then it's going to flip over the x-axis. And this one I want up 4, 1, 2, 3, 4. And again, that's going to flip over the x-axis to here. And then this one up 4, 1, 2, 3, 4. And it comes over here. And that's it. Good luck. Have a great spring break.